All right, let's dive into the incredibly complex world of cybersecurity. But we're going to look at it through a very specific lens, that of a policymaker. So if you're tackling this at a graduate level, or you just want to get your head around the challenges and solutions from that high-level perspective, this is for you. We're going to break down the key issues that are really shaping our digital lives. Now, to make sure we're on solid ground, our guide for this whole discussion is a nonpartisan report from the Congressional Research Service. And this is the exact same kind of material that informs debates on Capitol Hill. So what we're getting here are insights straight from the source that advises the policymakers themselves. So here's our game plan. First, we've got to define what we even mean by cyberspace. Then we'll get into the anatomy of a cyber threat. Who's out there and what are they after? After that, we'll cover the core pillars of security. Then we'll try to navigate the policy maze. And finally, we'll look at the actual toolkit Congress has to deal with all of this. Okay, so let's start with what you'd think is the easy part. We all say the word cyberspace every day, but when you have to write laws about it, well, defining it becomes surprisingly tricky, and getting it right is absolutely critical for any effective policy. Here's the official take from the Cyberspace Solarium Commission. As you can see, it's broad. It covers everything from your laptop to the power grid. And, that's a decent starting point, but it really only scratches the surface of the problem we're dealing with. And that's the real question, isn't it? Because for someone trying to write a law, just saying it's about computers doesn't help. It doesn't capture this incredibly complex web of global supply chains, private companies, and billions of individual users. The reality is just so much messier than that. Just think about the smartphone in your pocket. It's the perfect example. It was probably designed in one country, physically built in another, and it runs software written by developers all over the world. Then it connects to this massive patchwork of private and public networks. See, cyberspace isn't some single defined place. It's a sprawling global ecosystem. Okay, so now that we have a feel for the landscape, let's introduce the villains of the story. Who are these threat actors, and what are the vulnerabilities they're constantly trying to exploit? So threats basically come in two main flavors. You've got attacks that target cyberspace itself, stealing data, crashing a network. But then you have attacks that use cyberspace as a weapon to cause chaos in the real world. A perfect and frankly terrifying example of this is a ransomware attack that locks a hospital out of its own patient records, basically grinding patient care to a halt. Now, this chart is really interesting. It breaks down the major players that the U.S. intelligence community is worried about. You've got nation-states like China, who are primarily focused on espionage, and Russia, who's looking to disrupt military and foreign policy. Then you have countries like North Korea, using cyber attacks basically for theft to fund their regime. And of course, transnational criminal groups who are in it purely for the money through things like ransomware. But here's the thing. It's not always about a malicious actor actively trying to break in. Sometimes the threat is just built into the system. The Log4j vulnerability was a huge wake-up call for everyone. This was a flaw in one tiny, super common piece of open source code that suddenly put millions of servers and all the data on them at risk. It's a stark reminder that threats can come from simple human error just as easily as they can from malicious intent. So, with all these different kinds of threats flying around, how in the world do we even start to build a defense? Well, it all comes down to three fundamental principles of information security. And understanding this framework is absolutely essential for any serious policy discussion. It's known as the CIA triad. And no, not that CIA. It stands for confidentiality, integrity, and availability. These are the three core goals that any secure system needs to achieve. So let's quickly break down what each of those really means. First up, confidentiality. This one's pretty simple. It means keeping secrets, making sure data is only seen by the people who are supposed to see it. It's compromised, obviously, in a data breach. And its main line of defense? Encryption, scrambling data so that it's just gibberish to anyone who doesn't have the key. Next up is integrity. This is all about trust and authenticity. It's making sure that data and systems haven't been tampered with or altered without permission. It's compromised when an attacker manipulates data, and it's protected by things like data checking tools, like hashing, which basically create a unique digital fingerprint to prove nothing has changed. And finally, we have availability. This just means that authorized users can actually get to their data and systems when they need to. The classic attack here is, of course, ransomware, which locks you out of your own stuff. And the number one most crucial defense? Regular, secure data backups, so you can just restore everything and get back to work.
Okay, so we've got the technical foundations down. Let's zoom way out now into the world of policy. And this is where things get really, really complicated. We're talking about a tangled web of different players, shared responsibilities, and of course, global connections.
So here's the most important thing to understand. No single person or group is in charge of cybersecurity. Governance is what we call a shared responsibility. You can think of it like a digital neighborhood watch where everybody, the government, the companies making the tech, the service providers, and yeah, even you, the user, has a role to play in keeping the neighborhood safe. And the Internet of Things is the perfect example of this global puzzle. I mean, think about it. You can have a smart security camera that's built in one country, sold in another, then it gets infected by malware from a third country and gets used to attack a target in a fourth country. Suddenly, a simple technical problem becomes this massive, thorny international relations issue. Okay, so that brings us to our final section. We've defined the domain, we've identified the threats, and we've waded through the policy maze. Now for the payoff. What can policymakers in Congress actually do to make a difference? And that's a fair question, right? When a problem is this huge, this global, this complex, it can feel like trying to nail Jell-O to a wall. But the good news is, Congress does have a pretty wide range of tools it can use. This slide gives you a sense of that toolkit, and let's just pick out a few key ones. They can regulate, right? They can set mandatory security standards for critical industries, forcing them to up their game. They can also incentivize behavior, offering grants to state and local governments to help them beef up their own defenses. And they can establish rights by creating clear data privacy laws that give citizens more control over their own information. These are all powerful levers Congress can pull. And all of that leaves us with one final, really critical question to think about. As technology like AI and quantum computing just keeps evolving at a blistering pace, how is this delicate dance of shared responsibility going to change? Who's going to be on the hook for securing our digital future? That is the core challenge that policymakers, and frankly, all of us, are going to be wrestling with for decades.